Yes. Do you remember? Yes.
No, sir.
Oh, Ifat, do you remember what is the magnitude of this vector? You also went, okay. So what we do is that we have this x, y, z coordinate, right? And we move along this x direction, so that is called the I hat direction. This direction is called the j hat, and this direction is called k hat direction, right? So let's say I move 4 units in x direction. So my vector would be 4I, right? Siddhika and Ifan.
Yes, sir.
And let's say then I move, yeah, then I move 5 unit in y direction. Right? So this is 5j, but this would be 4I plus 5j, right? So this point would be 4I plus 5j, and this is 4I, right? This is 5j. And let's say from this point I move in the k hat direction. K hat direction is not in this screen, right? This screen is 2-dimensional. So k hat direction would be where? Can you guess, Siddhika? K hat direction would be where?
Forward, like,
Yeah, coming out of the screen, right?
yes.
Coming out of the screen. So let's say this is this, and let's say I move, let's say 2 units in k direction. So this is 2k, right? So this vector would be then 4I plus 5j and plus 2k. Right. So this is the position vector that I am at right at current. So this position is 4, 5, right. So it has the x component, it has the y component, and it has the z component. So I can write any vector as the form of the x component, y component, and z component, right? And a vector has how many components or how many parts? Yes, a vector, 2 part, right? 2 part, and that is the magnitude, and this is the vector, right, Siddhika? And
Yes, sir.
yeah, so this part is the magnitude part, right? And this part is the direction part. Okay, so this is also called the unit vector. And by when I say unit, which means that it has magnitude equals to, right? So this A hat only represents the direction of the A vector, right? Let's say you have A vector. So this is the geometrical representation of a vector. So you can see that it has a tail and it has a, and this length describes the magnitude, and this arrow, this head describes the direction, which is the A vector. Okay, so this A vector has this magnitude and this direction. Understood, guys?
Yes, sir.
Yeah, so we can write A as AX, I, AY, J, and AZ. But we want to calculate the magnitude of this vector, right? So the magnitude is defined as root of AX square plus AY square plus AZ square. Okay. And it will also have a direction, right? So how can we calculate the direction? So we know that the vector is magnitude into direction. So we can calculate this direction, which is the unit vector, by dividing it with the vector. Understood?
Yes, sir.
Yeah. So this part is only needed to do these problems that we were doing in the. So in the first class when Rishita and Arthur go there. So yeah, Rishita, I also gave you guys some homeworks. So did you guys completed that homework? Yes, Rishita.
I didn't complete all three, but I completed like two.
Two. Yeah, so you didn't send me any of those. So you send me at least, but you didn't send me any, right?
So can I send it to you today?
Today, yeah, please do that, right? So that I can see whether you have done it right or not, right.
Sir, can I have your number?
My number. I can contact you through this Learnivio number, and you
So
can.
where are you getting her answers from?
Yeah, so Rishita will send it to the Learnivio team, and then they will.
Okay, sir.
Okay, so yeah, so A is this, B is this, then magnitude and direction of A plus B. Right, so let us do this problem. Let us solve. Okay, Rishita, what we will do is that we'll solve this homework here. Okay, Rishita, and you can check.
Sir, I've already written it. Should I write it again or just leave it?
Oh, so then let us skip these three problems. Okay.
Okay,
And let me repeat two or three problems so that Siddhika and Ifat can understand these problems. If it's okay with you, Rishita.
Yes, sir.
Yeah. So let me repeat these questions. So let us start from okay. Forget about these answers, right? And let us do two or three problems. Then we can understand this. Okay. So we have this P plus Q is a unit vector along x-axis, right? So we have two vectors P. We have two vectors P and Q, right? And their sum is what? A unit vector, right? A unit vector along x-axis. Yeah, yeah. So unit means one, right? Magnitude is one along x-axis. So what is the unit vector along x-axis? Ifat and Siddhika. So we have this x-axis, y-axis, z-axis. So along x-axis, what is the unit vector? Yes, Siddhika. We just talked about this just just a few minutes ago. So unit vector along the x direction.
1.
So one is only a magnitude, right? So yeah. Ifat said I. So is the right answer, Siddhika?
I cap.
Yeah, I cap. So is this the right answer? I cap. Can you agree with Ifat answer?
Yes, sir.
Yeah. Okay, so okay. So I had or I cap is the unit vector along x axis. Along y axis, what is the unit vector?
J cap.
J cap. And along z we have Q cap. Right. So in this question, P plus Q is a unit vector along x axis. So these four words suggest to what? This I cap. Right. Unit vector along x axis is I hat. Right.
Yes, sir.
So P plus Q would be how much? Yes. So P plus Q is meaning equal, right? A unit vector along x axis. So what is a unit vector along x axis? Just you see. Right. So Ifat and Siddhika, what would be P plus Q would be what? From this information. Yes. So P plus Q is a unit vector along x axis. Right. P plus Q is a unit vector along x axis is what? Just a moment ago, you said the answer. I, right. So one I we can write Ifat we can write I. So does this represent this information? P plus Q is a unit vector along x axis. So does this equation represents this information? Siddhika.
Yes, sir.
So this is, yeah. So this is what is the meaning of these sentences or these information. But what is given? If P is this, right? So value of P is given. So we can put the value of P in this equation. This is I minus J plus K plus Q vector is I. Okay. So I will cancel and Q would be, this will go in the right hand side, so this will be J minus Q. Right. So any doubt in this problem? Siddhika
No,
and,
sir.
okay. So we will skip this question. The magnitude of a given vector with n terms. Okay, yeah, this question is important. So, yeah, did you guys note down this problem?
1 second, sir. I'll write it down.
Yeah, please. Rishita, so today I wanted to, not today, but on Saturday I wanted to start this resultant of the vectors. So, yeah, I will do 3 questions from this and then I will start with it. So please,
Okay.
yeah, please bear with us for a few minutes. Okay, Rishma.
Yes, sir.
And this will be like a revision for you, right?
Yes, sir.
Okay, done, guys. Before time,
Yes, sir.
Okay. So, yeah. So the magnitude of a given vector with n points, this and this. So we have to find the magnitude of a vector which is from this point and this point, right? 4 minus 4 will be somewhere else, but let me write it else. Okay, so we have this coordinate system, right? X and Y. And position of this A point is here. And position of this B point is here. So if A is 4 minus 4, so what vector will represent this position? Siddhika.
J. J
So,
cap.
so J cap meaning this is only in the Y direction. Is this point only in the Y direction?
No, sir.
Yeah, so this has X part and Y part only, right? The Z part is 0. So what would be the vector that represents this point? We have x component, right? We can write any vector as x component, y component, and z component. Remember?
Yes, sir.
So what is the x component?
4,
4. And y component is
-4.
-4. So what would be the vector?
4 I cap.
Yes, you are right. You are right. You are going in the right direction. And
-4 J cap.
yes, absolutely. So this is the position vector of this point, right? And Ifat, can you tell me what would be the position vector of this point? So this is what? This is -2. -2. Actually, the points would be here, right? Actually, the points would be this is plus, this is minus. Yeah. -2, yes, absolutely correct. So RB is -2I and -2J. Okay. So the displacement would be this way. This would be AB, right? So RAB would be this vector minus this vector. So RB minus RB. So this represents the distance between two points. Understood, guys?
Yes, sir.
Yeah, but what I was saying that 4 minus 4 point will lie on this is plus plus, this is minus plus, this is minus minus, this is plus minus. So 4 minus 4 will lie here and -2 will lie here. So sorry about that. Just for to make you guys understand, I have gone these points here. Okay. So you know that the points will lie here and okay. Yeah. So what would be RB minus RA, guys? RB is -2I minus 2J and minus of 4I minus 3J. Right?
Yes, sir.
So this is -2I and -4I, so -6I. And -2J plus 4J. So that would be 2J. This is the displacement vector between two points. Okay. And Siddhika, you tell me what would be the magnitude of this vector? Yes. They want us to calculate magnitude of given vector with these endpoints. Yes. Recall that if you have a vector A, which is AX I hat plus AY J hat plus AZ K hat. So magnitude of this vector would simply be AX square, AY square, AZ square. So what would be the magnitude of this vector? So
4.
4? No, this is vector addition. This is vector addition, right? Not the algebraic addition. -6 plus 2 is 4, so not that. So you see that what is AX? RB has RX I plus RYJ and RZ is 0. This is 0. So magnitude of RAB would be simply root of Rx square, just like this, and Ry square. Is this clear, Siddhika? And if
Yes,
I,
sir.
so this would be simply root of -6 square and 2 square. Right.
Yes, sir.
So this would be 36 plus 4. Yeah, so Ifat has already calculated this. Yeah, so root of 40. So this is 4 into 10. Right, root 4 is 2. So 2 root 10. Okay. So whenever two coordinate points are given, so let's say R1 and R2, and this is X1, Y1, Z1. This is X2, Y2, Z2. So you calculate this displacement by just subtracting the position vector of these. Just remember this. Okay, guys.
Yes, sir.
Yeah, so please quickly note it down, and then yeah, please quickly note it down, and then we'll do the 52 problem, and then we'll go to the result of the. For you guys, I will repeat this part again, because Nishita may be getting bored, so we'll start.
No,
with- No. Okay, so let me do two more problems. Okay, Rishta.
okay, sir.
Yeah. Siddhika and Ifat, you guys. So Ifat has already reached the answer. So Siddhika, you please input out. And any doubt, Siddhika, do you have?
No, sir. Could you scroll down?
Yeah.
Done, sir.
Okay. So let's do this 52 problem and 53 problem, and then we'll do the next one. Okay, so problem number 52. The expression this 1 by root 2 I plus 1 by root 2 j is a unit vector, null vector, vector of magnitude root 2 scalar. So first question is this a scalar quantity? Siddhika and Ifan. Is this a scalar quantity? Yeah. No, right? Because you have this I, J, K directions. So if whenever you have direction, so this cannot be a scalar quantity, right, Siddhika?
Yes, sir.
So this option is right, discard.
It's a unit vector
Oh, so how can you say that it's a unit vector?
because I cap and the J cap.
Because I cap and J cap, but you have these numbers, right? So let's say 3I plus 4J. These are these numbers. So this cannot be only I, J, K independently are unit vectors, right? But
Yes, sir.
if I write 3I, which means that it has 3 magnitude in the X direction, 4 magnitude in the Y direction. So yeah, but your answer is yeah, we will talk about that. Okay. So is this a null vector? Is this a null vector? What is a null vector, Siddhika and Eva? Yes. Null vector, which means that whose magnitude is 0. Right. Magnitude is 0. So that is called a null vector. And it has not, it doesn't have any direction. Right. So this has I, j, k direction, and this doesn't give 0. So this is not a null vector, right? So it can be a unit vector, it can be vector of magnitude. So what is the property of the unit vector, Siddhika? What is the definition of a unit vector? Yes. What is the definition of a unit vector? So unit vector only represents the direction. What is the magnitude of a unit vector? Yes, Siddhika, what is the magnitude of a unit vector? So I, j, and k are the unit vectors. So what is the magnitude of I?
1.
1. Right. That is why it is unit vector. J magnitude is 1. So whichever vector whose magnitude is 1, so that will be called a unit vector, right?
Yes, sir.
So to show that any of a given vector is a unit vector, we have to prove that its magnitude is how much?
1.
1. So let us calculate the magnitude of this vector. 1 by root 2 I hat plus 1 by root 3 j hat. So what would be the magnitude of this vector? Yes, Siddhika. Magnitude of this. So this is
Root square, but
yes,
all of it under root square.
yeah. So this square and this square. Is this what you were saying?
Yes, sir.
Yeah. So 1 by root 2 square is how much?
1 by 2.
1 by 2. This is also 1 by 2. Half plus half is 1. Root of 1 is 1. So what is the magnitude that you get?
1.
1. So this is a unit vector. Understood?
Yes, sir.
Okay, so yeah, we can do one more problem because Rishita has agreed. So let's quickly do one problem and then we'll start the next one. Okay, Siddhika, you please quickly note down this problem.
Sorry?
You quickly note down this problem.
Okay, sir. Done, sir.
Okay, so Ifat and Siddhika, you will be guys coming to Saturday class because you were not there in the previous class. You guys will be coming in the next class. Hmm? Yeah, so because you guys were not there in the Saturday class, right? So that's why I'm asking. Please be there, right? Because then we will be repeating all this question again, right? So yeah, so let's do this problem, 53 problem. So I plus j, right? This is some vector. And we have to calculate unit vector along I plus j. So let's say this is I is this much, right? And j is this, right? So this would be I plus j. Right, Siddhika and Ifat.
Yes, sir.
So we have to calculate what is the unit vector along this direction. Yeah. So we have to calculate what? This, right? this is the unit vector along A direction, right? This is A direction. Unit vector along this direction. Understood?
Yes, sir.
So how can we calculate this unit vector? Yes. We know already that A vector is A magnitude and A unit vector. So A unit vector would be how much? A vector divided by A magnitude. Is that correct?
Yes, sir.
So we have to calculate, yes. Yeah, so we have to calculate A magnitude, right? So what would be A magnitude? We have this vector.
I cap plus j cap under root square.
No, I cap. So 1. The x component is 1, right?
Yes, sir.
J component is 1. So 1 square, right? Magnitude cannot have directions. I and J are directions. So just be careful with that, right? Yeah, so this would be 2. So magnitude is root. So we can simply calculate the unit vector as A vector divided by magnitude. So this would be I plus J divided by root. So what is the answer? This one. Right, quickly note it down if then Siddhika, and so now we can start.
Done, sir.
Okay, so before I start the next topic, you guys please take some homework for Ifat and Siddhika. So take the screenshot of this 54, 55, and 56 question. Please take the screenshot of this question, Ifat and Siddhika, and
Okay, sir.
yeah.
Done, sir.
Yeah, and send me those ones. Okay, so the next topic is, and whenever if you have any doubt in the Cartesian form of the vectors, you can always ask. Okay. Yeah, so the next topic is this resultant of vectors in the polar form. So let's say you have two vectors, A and B, right? And the angle between them is given. So A are not given like this. AXI, B, AYJ, and AZK. And B is BXI, BYJ, BZK. But this form is not given. Right. Only the magnitude of A vector is given and the magnitude of B vector is given. And the angle between these two vectors is given. Okay. So to get the resultant, which is A plus B, we use this parallelograms law. Right. So what is the parallelograms law? What we do is that we place this B vector on the head of this A vector. And we draw the parallel to B vector. Right. So this is B vector. And then on the head of this B vector, we draw a parallel vector to A. So this would be B vector. Right. So what is the quadrilateral that we get? Yes. What is this quadrilateral? Now, is this a square or a parallelogram? Right. So it's a parallelogram and the diagonal represents the resultant of these two vectors. So this represents the resultant of these vectors. These are A, B, and this is the result. So whenever you have these kind of resultant, so just remember this diagram. This is the equivalent triangle that you get. So this is R, this is B sine theta, and this is A plus B cos theta. So Amna ma'am will tell you that how do we get these. Give me one moment. Yeah, rhombus. But for rhombus, it is not parallel, right? Rhombus is this. So for rhombus, all the sides are equal, not parallel. Right? For the rhombus, all these sides should be equal. Yeah.
Yes.
So, yeah, and the effective diagram that you will get. So Amna ma'am will tell you in the class that what is the effective diagram that. So this is the effective triangle that you get, and this angle is alpha. So the magnitude R can be calculated using the Pythagoras theorem. Right. So when we apply the Pythagoras theorem, we get this result. A square plus B square plus 2AB cos theta. Okay. And what is the angle? Tan alpha would simply be, so this is perpendicular, this is base. So what would be tan alpha simply? Yes. Yes, Siddhika, can you tell me what would be tan alpha? So in the trigonometric ratio, if this is perpendicular, this is base, this is hypotenuse. Right. So what is tan? Let's say this is theta. So what is tan theta? Perpendicular upon base. Right. Right, guys.
Yes, sir.
So perpendicular is b sine theta, yes. Yeah. So as e succeed, so this would be b sine theta divided by a plus b cos theta. Okay. So this is the resultant of two vectors, and the angle between the resultant and the one of the vectors A. Angle between R and A. Okay. So this alpha is angle between the resultant and one of the vectors, and this is the magnitude of the resultant. And this R is A plus B. So this is what we call the polar form. Addition or the resultant in the polar form. So up to what point Amna ma'am has done this part? Siddhika and
She only gave a basic introduction, sir. She didn't even get into this.
Oh, so she has not. Okay, so maybe in this week she will complete that. So yeah. So just remember this part. That for the resultant is in vector representation. This is this, and the magnitude of this R is a square b square to b cos theta, and this is the angle. Okay. So this part is the most important part. When you can remember this, so then you can calculate this size. Okay.
Yes, sir.
Understood. So there are three conditions. There are three special cases for this result. So three special cases for resultant of vectors. Oh, before I do that, you guys, so Sitika and you guys, please quickly move it down. Forget this part and quickly move down this part. Okay.
Yes, sir.
So whenever I ask you resultant, just remember this part and this part. Okay.
Yes, sir. Done, sir.
Done. Ifat done. Yes, Ifat. Okay. So there are three special cases for resultant of vectors. Right. And let's say that one special case is that. So remember this diagram that we calculated the resultant when this was the angle, these were the two vectors. Right. And we know the magnitude of, A, magnitude of B, and the angle between A and B. Right. So these first special case is that when this angle is 90. Right. So this angle is 90 degrees. So this is A and this is B. So what would be the parallelogram? So then the parallelogram would be a rectangle. In this case, it is appearing to be a square, but if A and B are different, so this would be the result. Okay, guys. So
Yes, sir.
R would be A plus B, and the magnitude of R would be how much? Yeah, what is the magnitude? Rishita, what is the magnitude?
So root of a plus b,
No,
a square plus b square plus
Yeah.
2ab cos theta.
Yeah, maybe cos theta and
Cos 90.
cos 90. So Siddhika, how much is cos 90? Yes, cos 90 is how much? Ifat, cos 90 is how much? Sin 90
Zero.
is 1.
Zero.
Yeah, 0.
Zero.
Yes, 0 is the right answer. Yes, 0 is the right answer. So this part is 0. So whole part is cancelled, right? So we have R equals to A square plus B square, Rishita.
Yes, sir.
Not A plus B. Yes. So this is the one special case. Okay. And the second special case is that if theta is 0 degree. Right. If theta is 0 degree, which means that this is A, and this is B. So the angle between A and B is 0 degree. Right, guys? So R would be A plus B. And R is now, Siddhika, you tell me what is R? Yes. Yes, Siddhika. R is the magnitude of the resultant.
A square plus B square.
And plus there is 2ab cos theta is also there, right? So 2ab cos of 0 degree. Cos 0 is 1, right? So this is 2ab So what is a square plus b square plus 2ab? So this is the identity a plus b whole square. So this would give us a plus b. And this is the maximum value. Okay. Understood, guys. So I will talk about this third case on Saturday because there will be another class. So you guys quickly note it down. Okay. Quickly note down the two cases and we will do the question in the next class. Yeah, whenever you guys
I
need
could
to,
just go.
yeah.
Done, sir.
Done. Ifat, done. Yeah, and Rishita, we have already done this, right? In our class.
Yes, sir.
So yeah, meet you guys on Saturday. And yeah, Rishita, yeah. So okay, bye guys. Meet you on Saturday.
Thank you, sir.
Thank you, sir.